Welcome back. So this last video is going to be a little bit of a bonus lesson. The reason I say it's a bonus lesson is because we're going to cover how to bring in a stream of data from something like an Arduino into our p5.js sketch. So instead of using the mouse cursor as the data source, you'll be able to substitute something like a sensor you might have on hand. It's bonus because I'm not sure what you have available to do this, and also I know some of you will not have taken the Arduino course just yet or just about to start it. So if you haven't and you feel like this Arduino bit is a little bit in over your head, don't worry, you can always come back to it later in the semester when you're a bit more familiar with Arduino. And those of you who have seen Arduino before and are curious about what is the workflow, the process to go from the serial output on the Arduino all the way into p5.js, well, we're going to walk through this in this video lesson. So this is where we left off in the previous video, and all I've done so far is remix the program into a new sketch so I don't accidentally overwrite the other one. And what we're going to be doing is we're going to bring some data reading from a sensor that's connected to an Arduino board into the sketch, so that instead of using the mouse X coordinate as our data stream, we'll be able to visualize the data coming from that particular sensor. And we'll talk about the flow of information from the Arduino all the way into the P5 sketch. Now, in order to get serial data into P5, we have to use something called a bridge. Now, the reason for that is because P5 runs in JavaScript embedded inside the browser. And because of security limitations, the browser doesn't have the ability to directly open ports onto your computer, or serial ports, hardware ports. So it's not able to open something like, let's say, the serial communication between the Arduino and the computer over the USB cable. It's not able to do that from the sandbox of JavaScript and the browser. What it can do, however, is open socket ports. So sockets are ways that apps can communicate with each other, either on the same computer or on computers over the internet, and exchange information that way. So what the bridge does is it creates it's an application that's going to take data from the Arduino and then open one of those socket connections that can be accessed through the browser. And there is a great handy project called P5 Serial that does that already for us. So P5 Serial provides two components. So first, it provides a p5.js library that we're going to include into our sketch, and it also provides that application bridge. So in order to be able to relay the data from Arduino into a format that the browser is able to open, you're going to have this bridge application up and running. And there's a few different ways that it can be used, but we're going to use it not using Node.js. We're going to use it using just straight into the browser, and then we're going to use the P5 serial control application running on our computer to act as the bridge. Okay? But before we get there, let's just take a step back and talk about kind of the hardware setup we're going to be using for this example. So I'm going to be using an Arduino Uno board to which I've connected a really straightforward little sensor. Now this is my Arduino Uno, and I didn't have a sensor on hand for this demonstration, so I made one. This is one of my favorite types of sensors to use. This is using a technique called capacitive sensing. And basically what it does is it's one resistor. So if you want to try to replicate this circuit and you have the components, you can do it with just a resistor. You don't necessarily need the alligator clip here. And I have it attached to a coin as my sensor. But all it is here is a resistor. This particular resistor has a value of 1 mega ohm. You can use smaller or bigger values. The smaller the resistor, the less sensitive the sensor will be. And the bigger the resistor, if you go into the 10 mega ohm range, you can actually sense distance, which is quite nice. So the resistor right now is just folded in half, and it's going from pin 2 to pin 4 on my Arduino. And I've chosen these pins. I'll show you the code in a second. You can run multiple of these sensors as long as you have pins available And I've chosen 2 to 4 just because it's a little bit easier to bend it across and not have them touch each other. And the way this is set up in the code, pin 2 is going to act as the sensor. So I'm connecting a little alligator clip here to the end of pin 2. And I have the other end of my alligator clip hooked up to a coin. Now this could be any piece of metal. It could be a piece of tinfoil, whatever. It could be the alligator clip itself. And what you can do with capacitive sensing is you can sense proximity or contact of the human body to your sensor. The way capacitive sensing works is essentially it uses the digital pins to send a signal from one pin to the other. And the resistor, in combination with the wire and whatever you chose to use as your sensor and somebody's body, creates a filter of sorts that's going to affect how much it takes for a signal to go from one pin to the next. And that can be measured. There's a library I'll show you on Arduino that does all of this work for us. That can be measured, and this is what essentially becomes our sensor reading. It's technically measuring something called capacitance, but for all our intents and purposes, we can think of this as a touch sensor. And it's going to have an arbitrary reading, as we'll see in a second, which, the ideas of minimum and maximum are going to become really handy here because that number is going to be different based on the environmental condition, the size of the thing we chose to hook up to it, and so forth. So it's very simple sticker to replicate. If you have that equipment, you can try to do that yourself. Or for, you could hook up any other sensor to your Arduino at this point. You could hook up a sensor to one of the analog pins, right? If you have that type of sensor, you could read a potentiometer, or you could set up a photocell. As long as you get some kind of number in your Arduino code that you're then going to pass on to p5.js. So this is the hardware setup. And on the software side, I'm using the capacitive sensor library for this example. This is a very short program. In order to install the library, you go under Manage Libraries. This takes a second to open usually. This is a library that you can search for. If you search for capacitive sensor and spell it correctly, this is the library that I'm using right now by Paul and Paul. So you can install the latest version if you want to follow along. And this is the basic little code example here that I'm currently running onto my Arduino. This purpose of this lesson is not to go in depth into this particular bit of Arduino code. I'm assuming here you've already seen Arduino before and can kind of walk your way through this. Even if you're new to Arduino, you could just replicate this code if you just wanted to try it out. It's not going to hurt anyone. So first we include the library, then we create the capacitive sensor object. This is coming from the library, and we tell it to use pin 4 and 2. Like I've said, I've done on my hardware, right? I have a resistor going from pin 4 to pin 2, and pin 2 is actually the pin that's going to be doing the sensing. Having done that, we open the serial port. So this is how Arduino, or at least the Arduino Uno, gets to communicate back with the computer, is through the USB serial port. And in the main loop of the program, we simply take a reading of the sensor, right, into this variable called value. The number 30 here basically tells the library to actually take 30 readings, not one, and then average them to get a little nicer value out of this. And then we print this value out to the serial port simply just as a number on one line. And then there's a little delay here that just makes sure that we don't send too much data. We slow things down a little bit. And if I were to open the serial port, this is what the Arduino is currently outputting. So I've already uploaded this sketch to my Arduino. And if I touch my sensor, as I'm doing now, you'll be able to see that the stream of numbers are changing, right? So the closer my finger is to the tuning, the higher the number. And this, in fact, can be used also even as a pressure sensor, because the harder I press, the bigger the number. Okay, so I can really get some interesting interactions out of that really simple circuit. So this is what we have. We have the Arduino sending this data stream, right, which in many ways is similar to what we've been working with this week, MouseX, except instead now it's my capacitance number. It's sending a data stream over the serial port, and our job now is to get that number over to our p5.js sketch. So I'm going to put this away, and we're going to switch to p5 serial control. Now the first step we have to do is get the p5 serial app. So if we click here, take the latest version. We have a few versions for depending on your operating system you can download. I'm using Windows, so I've already downloaded this, and this is what I got when I unpacked the package. I get an app here called P5 Serial Control. I'm going to open this app, and this is going to act as the bridge between the Arduino and the p5.js sketch running inside the web browser. So my Arduino is connected on COM5. Yours, it's going to be on a different port. If you're on a Mac, this is going to look like something like /dev/tty something. By now, if you're familiar with Arduino, you should be able to figure out which one is your COM port. You can also get these through the ID of the Arduino, right? You can look at the different ports that are available over here. So this is the same name that you would use inside this app. So I'm going to open the port. Okay. And then we can see that this works if we enable the serial console. Okay. So now I'm seeing a stream of numbers into the serial console. And you may notice these are not the same numbers I was seeing before. That's because it's not reading these as letters. It's actually reading individual bytes coming in. So we have the ASCII code for the digits, right, followed by, there's always 1310. That's the new line characters. Okay? So if I tick off this box, read in ASCII, it's going to now show me the same thing that the Arduino serial console was showing me. So the actual number readout that I'm outputting. Okay. Let me clear it here. There it is. Okay. So as long as this is connected and open, this program here is going to broadcast this serial console information over an internal socket that can be opened on the p5.js side using the p5 serial library. So I'm going to leave this running, and I'm just going to minimize the window. So this always has to be running in the background when you want to have your Arduino talking to your p5 sketch. So I'm just going to minimize that window and let that running into the background. I'm going to go back to the library's homepage. So now that we have the p5 serial app running, the other side of this, the other ingredient we need is the p5 serial port.js library. So this library is something we're going to add to our index.html5 on glitch.com. So we could either download the library, add it as a file, right? Or we could link to it, just like we're linking to the p5.js library itself. So I'm going to use the linking strategy here. I'm just going to copy this script tag, and into our program here, we're going to go into our index, and we're going to edit before the sketch. Okay, we're going to add another script tag that's going to be the p5 serial port.js library. So now we have two linked libraries. We have p5.js itself, we have p5 serial, and then this is our actual sketch we're working on right now. Okay. So let's go back to our sketch. So having done this, we can start to bring in some code that's going to read the data that's being sent from Arduino to our p5 sketch. Now, the cool thing about this little app here is that it's actually giving us some code that we can start to work with. So this is an example p5.js program, okay? And we're just going to dissect it first really quickly, and then we'll bring in only the components that we need for our purposes. So the first thing we can see here is that this is defining a serial variable. That serial variable is going to become a p5 serial port object. Okay? So let's do that into our sketch. We're going to define a serial variable, and then over here we're going to create a p5.serialPort object. Cool. Okay. Then having done this, we have some options. So serial.list is going to trigger a list of all the ports available, but we're going to skip that because I actually know which port I have, right? This is COM5 here, and it's kind of smart how in the auto-generated code, it used the COM that I used here to connect to my Arduino. So once I've created the serial object, I'm going to open that serial object on COM5. And then if you want to, you can implement a bunch of different events. Okay, so they're called callbacks, and they allow us to define, basically different events happening around the serial port and connect those events to functions that we provide. Okay, so in this example, they're tying this connected event to the server connected function. Okay, so that you could have some information, once you've connected to the server provided by p5 serial control, this function is going to call, it's going to provide some debugging information. Same thing, the list action gets connected to this function over here called getList, and so forth. So a lot of these basically just print out information to give us a little bit more context and just to know that we're connected and troubleshoot and so forth. The one that we're really interested in is the getData function. So this little function is going to run every time there's new data to be read on the serial port, and it's going to get stored into a variable for us to use later on. So let's focus on that one. So there's a data event, right? And it's being connected to a function called getData. So I'm going to grab only this portion over here and put it over there. Okay. Now this is probably generating some errors for me in the console because I don't actually have the getData function implemented yet. So let's do that as well. So we're going to create a function called getData. Okay, and now it's happy because I created this function. So what this mapping does over here, it says this data event from the serial object, right? When it occurs, I want to run this function, which is part of my code over here. And then let's see what they do on the getData function over there. So they grab the current string from serial.readline. So let's do that as well. Okay. Then they trim the current string. Now what trim does this is a function from the p5.js library. So what trim does is it simply removes the new line characters from the end of the data stream. So when we're printing from Arduino to serial, right, we print the number and then we add a new line at the end so that every number is in a separate line. So trim is going to get rid of these new line characters and just keep the numbers. Right? This is a little bit of error checking here so that if there is no data, right, if there is no current string or if readline return nothing, this will simply abort and return the function. So that's a good idea to bring that in too. Then this is going to log the number to the console. So if we wanted to be able to read it in the browser, we could do this. I'm going to skip that and just grab that last line over here. So they call this latest data. So this is going to be a variable that we're going to declare up here. So instead of latest data, I'm going to call this sensor data for this program. And at the top here, we're going to define a variable called sensor data. Okay. And I suppose we could, if we wanted to, just as a way of making sure things are going well here, throw a little console.log. So if you remember to open the console, you go into developer tools, right? Or you remember this shortcut, Control-Shift-I, which is very handy. And we can see the numbers flying by in the console over here. And as I put my finger on my sensor, I can see those numbers increasing. Pretty sweet. All right, so we're in good shape. Now, what we can do at this point is we can say, okay, well, this is going to run kind of behind the scenes, right? Because it's using this event model. So we don't have to call this function getData. The serial object is calling it for us. So as long as new data is coming in from the serial port, this got data function is going to run. So that's going to happen. And it's going to update the sensor data variable. So we can kind of treat it almost like one of the built-in variables now. And instead of mouse X here, we could go ahead and use sensor data. And then we could go ahead and use sensor data for our average. So now the graph here, oops. So funny things will happen here if we're not being careful. So one of the things that we have to remember is when we're reading data from the serial port, we're actually reading the numbers as text. And if you'll recall here, this was particularly obvious when we didn't read in ASCII, right? So this is the actual raw data being read by the serial port. And if we convert this to characters, we get the sensor readings that our Arduino board is outputting. So these are actually text. This is a string. Okay? And on the p5.js end, when we say serial.readLine, we're actually reading a line of text. We're trimming that string to remove the end characters. But over here, if we represent our sensor data as a string, we might run into some issues. Namely, the map function here is not going to be too happy when min and max are strings. Okay? It really expects to see number values here. This is one thing we have to always be careful with in JavaScript because it doesn't enforce strict types just like Java does. So it's up to us to make sure that our data or our variables contain the right format for the information. So the way that we take a string and convert it into its number equivalent in JavaScript is we use the parseInt function that comes from p5.js. So once we've done this, that string value, right, the characters representing the number, are going to be converted into the actual numbers that they represent so that we can use that number to do math. Okay? So going back to our sensor over here, we can see that the graph also is really adjusting its min and max values as soon as it sees some larger values from me touching the coin here. And on the left, we can see the sensor readings from just the direct touch, and on the right we can see the average version that's kind of taking longer to rise and fall because it's averaging the last 20 values. So we get to manipulate the data stream a bit and get a different shape out of it. All right. So to recap, right, this is the process to go from Arduino to P5. And this example here is a good one because using the mouse as a data source is a little bit boring. So here we can substitute any kind of sensor data that you might have lying around. Or if you don't have a sensor, right, you can make one using capacitive sensing. So first, the Arduino has to be outputting serial values, right? So it's outputting its data onto the serial port. So that could be coming from, in my example, a capacitive sensor, but this could be reading from directly one of the analog pins or getting that number from any kind of other sensor types, maybe reading from its the sensor's own serial port and so forth. Once that's done, this data gets read by the P5 serial control app, which acts as a bridge between the Arduino and the browser. Okay? And the P5 serial control basically is just a relay, right? It takes the data, it reads the serial port, it has access to it because it's an app running on our desktop, on our computer. Oops, I've lost my tabs here. It's an app running on our desktop, so it has access to the port. And then it sends this data over an internal socket connection that the browser is able to open. So as long as this bridge application is open, the P5 serial library, which we imported over here, is going to be able to do its job. And then in our sketch, it becomes very easy to use the serial object, right, which is created over here, that does all of the heavy lifting of talking to the P5 serial app to grab the data that's being sent over that socket connection. It's very important to point out one final thing before we wrap up, is that this socket connection is happening on internally on your computer. So even though you do have a public IP address here that in theory, like I think I could use, I haven't tested it, but right now I'm connecting to the socket connection internally. Okay? What that means is that Of course, I can read from an Arduino connected to my computer, even though this is running in a browser. Okay? But if I was to share this sketch with you, you wouldn't necessarily be able to read from my Arduino, or you would need my Arduino to be connected, right? So this is beyond the scope of this example. If that kind of stuff interests you, you should look into the NetArt course that Steve Daniels is teaching. So in this context here, we're only reading sensor data from an Arduino connected to our own computer, which means that even though, yes, the app is living on the browser on Glitch, it assumes that you have the Arduino connected to your own machine, right? So it's only doing this local communication. This is not sending the data to Glitch over the internet for everybody else to see. It's happening in the browser that's running on your computer, talking to the P5 app, talking to the Arduino on your desk. Okay? So this only works locally and not over the internet. It's possible to send that information over the internet to have a more kind of permanent type of installation, but that's beyond the scope of this this particular lesson. Okay? All right. So with that, I hope you enjoyed, and I will see you next week.